This week we're looking up, way up. While some mates are still arguing over rooftop panels and cloudy forecast, some of the world's brightest minds are thinking beyond. We're talking satellites that beam down energy from orbit. But before we dive in, we found that 60% of you aren't following us yet. Please do us a huge favor, hit that follow button and collect our episodes on plods.media. Your support means a lot. Thanks, guys.
Okay, let's unpack this because you sent over some really interesting material on space-based solar power. It might sound like science fiction at first glance, but as your sources highlighted, this concept's actually been around since the 1960s. And, thanks to some fascinating technological leaps, it seems like it's gaining serious traction now as a potential game changer for clean energy.
Exactly. And what's truly captivating, as you can see from the material, is this, audacious idea of moving our main solar energy collection off the planet into space. So our goal in this deep dive is really to dissect SBSP from all angles based on these sources. We'll look at what it is, fundamentally, how this seemingly complex thing actually works, why it's become such a vital area of research now, who the key players are internationally, driving it forward, the big obstacles still in the way, and, what the future might look like for it. And think about the implications for global power structures and meeting these massive energy demands, especially with AI and blockchain coming online, which your articles also touched upon.
Right. So let's dive into the basics then, based on what we've got here. For those of us, maybe not astrophysicists, can you break down the core idea of space-based solar power?
Sure. So in essence, space-based solar power, SBSP, it's about collecting solar energy up in Earth's orbit and then sending that energy back down to the surface. The big advantage, and this was stressed in your sources, is the constant sunlight you get up there, uninterrupted. Unlike solar panels down here, these collectors in space work 247, 365 days a year, no clouds, no nighttime, none of that interference.
Collection.
Yeah.
Yeah, that sounds like a massive plus right away. One of your articles had some pretty impressive numbers on that. And you mentioned global coverage, too. How does that work, especially thinking about the different places mentioned in the materials?
Exactly. The benefits could be huge. That constant power tackles a key weakness of many renewables, right? The intermittency. And being in orbit gives you that potential for global delivery. A network of these satellites could theoretically beam power almost anywhere. That opens up possibilities for places without good energy infrastructure or places stuck using, less clean options. Several sources really hit on that energy equity point.
Okay, so massive solar panels capture sunlight. Got it. But how do we actually get the energy down here? It sounds incredibly complicated.
It does sound pretty advanced, yeah, but the principles are based on physics we understand quite well. As the materials outline, it's a few key steps. First, huge solar arrays on satellites grab the sunlight, turn it into electricity. Then that electricity gets converted into a form you can send wirelessly over long distances, usually microwaves or laser beams. And these beams are aimed very precisely at receiving stations back on Earth.
Microwaves or lasers?
Okay.
One source mentioned people might be a bit wary of that. Can you touch on the safety side?
That's definitely a crucial point, and it came up in the reading. It's important to get this across. The beams are designed to be low intensity, not like some sci-fi weapon. And they're targeted extremely precisely. Down on Earth, you have these special antennas, they're often called rectennas, designed just to capture these beams. They then convert that microwave or laser energy back into normal electricity, which, feeds into the power grid. And the beauty is no need for fuel up in space to generate power and no need for thousands of miles of transmission lines on the ground. It's wireless power, but on a massive scale.
No fuel, no wires across continents. Wow, that's totally different. So based on what you read, why the big push now? Why all this global interest?
Well, the momentum we're seeing, and it's clear in all the documents, comes from needing solutions and having the tech start to catch up. That continuous power supply we talked about, that's huge for reliable, clean baseload energy, something we desperately need. Plus the land use issue. Compared to massive solar or wind farms on the ground, SBSP needs much less surface area for the receiving stations. That frees up land.
Less land, constant power. Okay. Were there other big drivers mentioned?
Oh, absolutely. The efficiency, for one. You collect way more solar energy in space because the atmosphere isn't blocking or scattering sunlight. Some sources actually quantified that. And it's scalable. Need more power. Launch more satellites. That makes it really attractive long term. And finally, that point about accessibility, getting power to remote areas or places struggling with energy poverty. That came up particularly in one article about developing nations. It could make energy access much more equitable.
Okay, so it definitely sounds promising. Who are the main players then? Which countries or organizations are really pushing this, according to the info you gathered?
Your materials highlighted quite a few key groups globally. In the U.S., Caltech had that big success in 2023, actually beaming power wirelessly from space back to Earth. a real milestone. Then there's Japan through JAXA. They have really ambitious targets aiming for a 1 gigawatt operational station by the 2030s.
A whole gigawatt within about a decade. Wow.
Mm.
That is ambitious. What about Europe or other regions?
Definitely. The European Space Agency, ESA, they've got their Solaris program that's specifically looking into SBSP as part of Europe's clean energy future. One of the EU reports you had went into detail on that. And China, through CAXT, also announced plans for operational deployment around the same time, 2030. So there's clearly this international race or maybe collaboration shaping up. You also see private companies getting involved, like Emrod in New Zealand. They're working on the long-distance wireless beaming tech and have even done tests with ESA. And interestingly, the defense angle. Players like Northrop Grumman in the U.S. working with DARPA on military projects that could spin off useful tech for civilian SBSP, too. That dual-use aspect was mentioned.
Right, so lots of activity. But something this big must have equally big challenges. What are the main hurdles they still need to clear based on the sources?
Yeah, the sources were pretty consistent on the major roadblocks. First off, launch costs. Even though they're coming down, thanks to companies like SpaceX, launching all that hardware is still incredibly expensive. Then there are the tech hurdles. We still need R&D to make wireless power beaming super efficient over those huge distances. And how do you actually build these enormous structures in orbit? We need better techniques for in-orbit assembly, maybe robotics, plus finding materials that are lightweight, super durable for the space environment.
And space debris. That always comes up when we talk about putting more stuff in orbit. How does that affect SBSP?
It's a huge concern, yeah, mentioned in several articles. All the junk already up there poses a real collision risk for these big, delicate satellite structures. We need better tracking and ways to deal with debris. Then there's public perception, getting past the death ray fears about microwaves, Clear communication and solid safety rules are key. And finally, the rules. There aren't clear international regulations for this kind of space-based industry yet. Who owns what? Who's responsible if something goes wrong? That legal framework needs building out.
Okay, big challenges indeed. But your sources also seemed optimistic about progress being made. What are some of the key trends helping to overcome these hurdles?
Definitely some positive trends. One is robotic assembly in orbit. The idea of using robots to build these massive platforms up there instead of launching fully assembled structures could cut costs massively. We're also seeing real progress in beamforming tech, making the microwave or laser beams much more precise and efficient, less energy waste, better targeting, and the whole private space boom is a huge factor. More companies offering launches means lower costs and just more access to space, which fuels these bigger ideas like SBSP.
It all connects, doesn't it? Cheaper access enables bigger projects, better tech, makes them work more effectively. What about getting this power integrated down here?
Yeah, that's where AI comes in, as some sources pointed out. You'll need really smart grids managed by AI to handle potentially huge amounts of energy coming down from space, balancing it with terrestrial sources, making sure the grid stays stable. And that defense interest we mentioned, the military funding research into related technologies, even for their own reasons, can actually accelerate development for everyone. Those hybrid defense energy projects could be quite significant.
Okay, wow. We've covered a ton of ground, pulling from all these different documents. So what's your final take? Space-based solar power.
It still feels a little bit, bonkers.
It does have that slightly out there feel, I get it. But when you look at the science, the engineering progress, and the level of investment from major players globally, like we saw in the sources, it's definitely moving beyond just pure theory. And like you said earlier, it's crucial to frame it right. This isn't about replacing your neighbor's solar panels. It's about potentially creating a global, reliable, continuous, clean energy source, kind of like a utility-scale power plant, but in orbit. Think about places where grids are weak, or land is scarce, or where continuous power is absolutely critical. That's where SBSP could be truly transformative.
I'm thinking about the future with AI, data centers booming, decentralized networks needing power. That demand for reliable, clean baseload energy isn't going away. It's only growing, right? Exactly. Those technologies are incredibly power hungry. SBSP offers this potential pathway to meet that demand cleanly and consistently in a way that ground-based renewables alone might struggle with due to intermittency. It really feels like a logical, if ambitious, next step. We've already got internet beamed from satellites, why not energy too? So maybe the thought to leave listeners with is this. Reflect on the broader geopolitical landscape if a significant portion of the world's energy were derived from sunlight harvested in space. What novel international collaborations and dependencies might arise in such a scenario?